Today we learn the inner transition elements or the F block elements. So where these F block elements resides, we already know. Tahale, we know that these are the F block elements. Actually F starts from here. We also know that. Means what happens is 1s got filled up, 2s got filled up. Oh, sorry. 1s got filled up, 2s got filled up, 2p got filled up, 3s got filled up. Then 3p got filled up, then 4s got filled up, then 3d got filled up, 4p got filled up, then 5s got filled up, 5p got filled up, 4d got filled up before 5p. Now after 5p, 6s got filled up, 6s. After 6s, it is the turn of 4f to get filled up. So 4f gets filled up and stays here, and then 5d gets filled up, 6p gets filled up. Right or wrong? And then 7s gets filled up. After that, it is the turn of 5f to be filled up. Then 6d gets filled up and 7p gets filled up. We understand the predictable in this way. I hope that you have understood this. This has been taught previously also. Here our is given 1s, 2s, 2p, 3s, 3p, 3d, 4s, 4p, 4d, 4f. So after 6s, we want 4f to be filled up. So after 6s, we want 4f to be filled up. And after 7s, we want 5f to be filled up. So after 7s, we want 5f to be filled up. So this is what happens. This is how it is. Okay, so these are F block elements and the lanthanoid series. I hope you understand this. Okay, now the F block consists of two series, lanthanoids, the 14 elements following the lanthanum. Okay, the F block consists of two series, the lanthanoids, the 14 elements following the lanthanum. Means this is the filling up of 4f. Sir, why 14 elements? Why the 14? 14 because F has 7 orbitals. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7 orbitals. So 1 electron means increase in 1 atomic number. So the second one means 2 at third, fourth, fifth, sixth, 7 elements, then 8th element, 9th element, 10th element, 11th, 12th, 13th, 14th. So 14 elements will be there. Let us count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 14 elements are filled up. So we all here fills up the 4f, right or wrong? And here we will fill up the 5f, and 14 elements will be filled up. This is known as the lanthanum. This is known as the lanthanoids, and this is known as the actinoids. Yes or no? So the F block consists of two series, lanthanoids, the 14 elements following the lanthanum, and actinoids, the 14 elements following the actinium. They are called lanthanoids because they are following lanthanum, because lanthanum belongs to D block, don't forget that. Okay, so following lanthanum, that's why they are called lanthanum series, and following actinium, actinium itself is a D block element, and that's why it is called the actinoid series. See, because lanthanum closely resembles the lanthanoids, it is usually included in any discussion of the lanthanoids for which the general symbol Ln is often used. Okay. Similarly, a discussion of the actinoids includes actinium besides the 14 elements consisting the series. Means they are trying to say that when we will learn the 4f series and the 5f series, although lanthanum doesn't belong to the 4f series, but still we will discuss them with the 4f series, and although actinium doesn't belong to the 5f series, we will discuss them with the 5f series because of the similarity of the properties. That is what they are trying to mean. The lanthanoids resemble one another. the lanthanoids resemble one another more closely than do the members of ordinary transition. The lanthanoids represents one another more closely than do the members of ordinary transition elements in any series. मैंने यहाँ पे कोई भी सीरीज में एक जन दूसरे जन के साथ जितना क्लोज रिजेम्बलेंस है, यहाँ पे और ज़्यादा क्लोज रिजेम्बलेंस है आपस में. It resembles more closely with each other. That is what they are trying to mean. That is their introduction. They have only one stable oxidation state, and their chemistry provides an excellent opportunity to examine the effect of small changes in size and nuclear charge along a series of otherwise similar element. They have only one stable oxidation state, means oxidation state को लेके झमेला नहीं है, एक ही stable है. And their chemistry provides an excellent opportunity to examine the effect of small change in size and nuclear charge along a series to otherwise very similar elements. And so although they are very similar elements, but when we will move along the series, we will find that there is small change in nuclear charge and there is effective changes in the sizes. Means they are trying to talk about lanthanoid contraction, which we will learn, which we already have learned in D block also, but we will learn more here about lanthanoid contraction. So although the nuclear charge effectively increases by 1 here, but still the size, effectively decreases. And that excellent chemistry they are trying to say, examine the effect of small changes in the size and nuclear charge along a series. That is what they are trying to mean. Means nuclear charge उतना नहीं बढ़ेगा, फिर भी size घटता ही जाएगा. क्यों ऐसा हो रहा है? That we will try to understand. Yes or no? The chemistry of the actinoids is, on the other hand, much more complicated. Okay, the complication arises partly owing to the occurrence of a wide range of oxidation states in these elements, and partly because of their radioactivity creates special problems in their study. The two series will be well considered separately here. মানে অ্যাক্টিনয়েডে অক্সিডেশন স্টেট, যেমন এদের একটাই ল্যান্থানয়েডের একটাই অক্সিডেশন স্টেট কমন হয়, স্টেবল হয়, এদের মাল্টিপল অক্সিডেশন স্টেটস কমন হয়, and we'll consider them separately, and অনেকগুলো and they are radioactive. Actinoids are radioactive. That is the reason they become complicated. But I don't know, maybe actinoid is not there. I'm not sure. Let me check it out. Okay, let's go to the next video.